So for this chapter, we're going to kind of go back to geometry a little bit and talk about the parts of geometry, points, lines, planes, and we're going to get into finding perimeter, circumference of circles, area, volume, lateral, and surface area. We're going to talk about all that stuff again. So a lot of this you probably saw in geometry, which I know was a couple of years ago. But we have used some of these formulas already because we have talked about area and perimeter in previous chapters. So some of what we do in this chapter should be review or have been something that you guys have seen. What we're going to focus on this first section is just kind of some of the basics of geometry, like how to name points, lines, planes, angles, the different types of angles, angle pairs, and those kind of things. So back when you guys were doing geometry, you spent a lot of time going over like what makes up shapes, kind of what are the parts of shapes, what are parts of angles, points, lines, planes, and all of that stuff. So we're going to go over some of those things again here first. Remember that a point is a location or a position in space somewhere. It doesn't have a size or a dimension. It's just kind of talking about the location of something. Points are usually notated with like a dot somewhere, and then you usually have a capital letter like A next to it. The first time you guys probably saw points was when you were graphing on the coordinate plane. So you were just going like left, right, up, down to get a point, and then you guys, if you had a bunch of points, we would name them with capital letters so that if I was looking for a specific one, I could go to that letter that you had labeled. Now, lines contain points. They have to have at least two. So you can't have a line with just one point because it has nowhere to go. It has to have at least another point to connect to. But lines actually contain an infinite number of points because they go on forever and ever and ever in both directions. So lines have arrows on either side of them to let you know that they continue to go on. And again, they can have points on them, like 2 points, or they could have multiple points. Now, if you wanted to name a line, like this one, you use 2 capital letters, any 2 that are on that line, and then the symbol is just to draw like a little line above those letters. That's kind of the notation that we use. The reason why we talk about naming it is because we also have things like line segments and rays, and those are a little bit different than a line. So they all have different notation. Now, when you start getting a bunch of points and a bunch of lines, that's when planes start to come out. So planes are flat surfaces. Again, they also extend forever in all directions, so they continue to grow, just like lines do. Most of the time, planes are kind of thought to be rectangular, but planes can really be any shape. Like they could be a triangle, they could be a circle, they could have 5 sides, 6 sides. It doesn't really matter. It's just a flat surface. And inside of a plane, you could have lines that intersect. You could have points in the plane. Really, the kind of like big rule that you have to have for a plane is you have to have 3 non-collinear points. Non-collinear means that they're not on the same line. So you have to have 3 points that aren't all able to be connected with one line. And that's what kind of creates a plane. So now getting into the different parts or the different types of lines or line segments that you might see. A line segment is talking about a specific part of a line. Because lines go on forever, we can't measure a line because it would keep growing. But if I'm looking at a specific part of the line, this is called a line segment. So it starts and stops at distinct points that we call end points. Okay, so like back up when I drew my picture of my line, I had points A and B on there. A and B, if I was just looking at the line that went between those points, A would be an endpoint, and then B would be an endpoint. So this is the only difference, is that it kind of cuts that line down into a smaller segment. It doesn't continue to go on for ever in both directions. If I wanted to name this, I could still use those 2 capital letters A and B, but this time instead of drawing a line with 2 arrows, I just draw a flat line to let the reader know that's a line segment, not a line. I'm looking at a very specific part of the line there. The other thing is a ray. And rays come in when you start talking about angles. So a ray consists of a point on a line and then all the points that go in the same direction from that starting point. So again, that starting point is like your end points. So again, I could use like A, but this time I'm only looking at like one half of the line. So it continues to go off in one direction and it has a bunch of points on that. It could go in the other direction too. It doesn't have to go in that direction, but that's what an example of a ray would look like. Now to name a ray, again, you use two capital letters and it doesn't matter which two. So I could use AB or I could use AC. And I just draw like half of a line on top to kind of show that it's a ray. So they have different notations to let you, like if you're reading a problem, or to let someone else, if you're writing down answers, like me, if I'm looking at your work, I can see that you understand what's the difference between a line segment, and an array, because they are different from each other. Now, lines can do a couple of different things. And this comes in when you're talking about like finding solutions to systems of equations and that kind of stuff. So remember, lines go forever in either direction. They can go forever and ever in both areas there. And if two lines are drawn in the same plane, there's three scenarios that can happen. The first one is that they intersect at one and only one point. So it looks something like this. Those are two separate lines. They cross here in the middle at that one point. That would mean that those two lines have one common solution. At one point where they cross is that common point that they each have and share. The second situation is what we call coincide. Coincide basically means that they're the same line. So it's one line, and they share all the points on this line. So for example, if they gave you this picture, and they said, are like AC and BC the same line, you guys should be able to say yes, because they coincide. They're on the same line there. They all share those points. This would mean that if I was solving a system like this, I would get the same equation twice, so they would share all points. They would have an infinite number of solutions, because any point that's on one line is going to be on the other one if they're the same line. So they're going to share all of those points. The last case then, so if you guys turn the page over, the last case is when they never intersect. What kind of lines are those called? When they never cross. Parallel. Okay, so these are called parallel lines. They would look something like this. Okay, they never cross. They don't have any points in common. They'll always just sit side by side. If we were to look at the equations of these lines, they would have the same slope. So they would be going at the same rate. They would have the same rise over run forever. All right, so what we're going to do next is they're going to give us a picture. And we're going to use this figure here to answer the questions that they give us. We've got 4 questions that we need to answer. So number 1 wants us to name a ray with an endpoint of Q, and it passes through point P. So Q is the endpoint. That means that that's where the ray starts, and then it's going to P. So if you guys are on the line, you're starting at Q, you're going to P. So kind of following the arrow that I highlighted up there. So to name that ray, we would call it Q first and then P, and put the symbol for a ray on top of it, which is just like a one-sided arrow. Number 2, do the lines LN and MN represent the same line? You guys think so? Why? LM and MN, why are they the same line? Well, they're all on the same line in the picture, right? They're on that green line. They're all connected. Why? Mine's green. How about PQ and QP? Would that represent the same line segment? Yes. It's just naming it differently, but it's still talking about this area right here between those 2 points. Okay, so it doesn't change whether you put P first or Q first. So that's another yes. Can you guys name 2 lines that would be parallel to each other? PQ and RS would be parallel. Now, you don't have to say PQ, you could have said MQ, you could have said QM or QP, you can switch the order that the letters are, it doesn't matter, just as long as they are on those parallel lines. So like you couldn't have said LN and RS because those intersect, those aren't parallel. All right, so let's spend some time talking about angles now. So angles are another geometric shape that are formed. This time it's using rays. So it's when you have two rays that have a common endpoint. That endpoint is known as the vertex. So if you guys are looking at this angle here, A is called the vertex. AB and AC, those are the two rays that make up this angle. Those are known as your sides. So AB would be a side, and AC would be a side. Those are kind of the basic parts of an angle. Now, angles have an interior and an exterior. So anything in between those sides would be known as the interior of the angle. So there could be some points in there, and then anything on the outside of that too would be on the exterior of that angle. Now, to name angles, you can do this in a couple different ways. First way is if you're using a number. Now, this one up here doesn't have a number, but let's say that right here where A is at that vertex, they called it a number 1. Like they put a 1 there, or 2, or 3. You could name it using that number then. So you could say this is angle 1, or angle 2, or angle 3, whatever that number is. The next easy way to name an angle is just to use that capital letter that's by the vertex. So this one would be angle A. Now you can only do that if there's a singular angle in the picture. If I started having lines coming off of A like this, I now have 3 or 4 angles actually that are coming off of A, so I'd have to be a little bit more specific. Because if I just said angle A, someone would be like, well, which one? There's 4 of them that have A as its vertex. You've got the 1, the 2, the 3, and the 4. So when that happens, when you start having these other lines being drawn in and you have to be a little bit more specific about your angles, that's when you use 3 capital letters. Really, the only important thing is that you guys keep the vertex in the middle. So I could name this angle BAC, or you could do CAB instead. Notice how A is in the middle both times. That's because the vertex is always stuck in the middle when you're naming an angle. That way we know where the vertex is and we know like what angle you're talking about. But again, the order doesn't matter with B and C. Those are interchangeable. You can flip them around. A has to be in the middle. Okay, so you guys, on this example, I want you to write down the 3 ways to name this angle using the number, using a capital letter, using 3 capital letters. I want you to do all 3 of those by yourself here. Okay, how would we name it with 1 capital letter? Good, angle X. How about 3 capital letters? Or what's the other way? Good. How about angle, or naming it with a number? Good, 1. Angle 1. Okay, so now that you guys know what an angle is, or you've been refreshed on the parts of an angle, kind of how to name it, we also have different types of angles. This is classifying it according to size. Okay, so right angles. You guys remember what right angles equal? Good, 90 degrees. Now, perpendicular is kind of a key word that happens a lot when we talk about 90-degree angles. This is when you have lines that intersect, and when they cross, they almost form like a perfect T, and they create 90-degree angles. So like my ceiling, all of these where the tiles meet, kind of the supports, those are all perpendicular to each other. My bricks on my wall, all of those are crossing at perpendicular angles there in the middle. So anytime that you have 2 lines that form 90-degree angles when they intersect are called perpendicular. An acute angle has to be greater than 0 degrees, but less than 90 degrees. You can't have a 0-degree angle, otherwise it doesn't exist. So that's why it has to be greater than that. So it could be a teeny tiny angle, but most of the time it's anywhere between 0 and 90. So we would say greater than 0 degrees, less than 90 degrees. So what do you guys think the qualifications for an obtuse angle then would have to be? But less than 180. Okay. Now, because if it's equal to 180, that's called a straight angle. That's when it looks like a line basically because it lays flat. Okay, so what we're going to do is just kind of practice classifying them according to their size. Now, if they don't give you a measurement, use your best judgment on what kind of angle you think it might be. So for number 1 here, we've got 4 different angles in this picture. Which angles do you think are the acute angles? Good, angles 1 and 3. So what type of angles are 2 and 4? What would you call them? Obtuse. Okay, and there are really some problems where they actually give you the measurement, like they say 54 degrees, 112 degrees, something like that. You use the same kind of rules as we talked about before. These ones I was just kind of looking off of based on what they look like. It looks like 1 and 3 are less than 90. 2 and 4 look like they're greater than 90. What about number 2? What do you think they're equal to? All of them? So what tells you that they're all right angles? Okay, so 6 has a square, and that square is kind of our clue to let you know that this is 90 degrees. These lines would be considered perpendicular then, because where they cross, they form one 90-degree angle. And we haven't talked about these angles yet, but we have kind of angle pairs happening here. So if 6 is 90, 5, 7, and 8 are also all going to be 90 degrees. How about number 3? What kind of angle would this be? 180, which we called it what? Straight. Because it looks like a line. All right, do you guys remember what complementary means? Yeah, you're on the right track. Complementary means that they have to add up to 90. So complementary angles are when they add up to 90 degrees. To find the complement of an angle, you just subtract its measure from 90. So supplementary is when they add up to 180 degrees. And so to find the supplement of an angle, you subtract its measure from 180. So if I'm given the angle 57 degrees, what would be the complement? How much? Complement. That's the supplement. Supplement would be 123. What would be the complement? 33. Okay, 33 to 57 would get us to 90, so that's the complement. 123 to the 57 would get you to 180, so that's the supplement. What do you guys remember about the word congruent? Like, what does it mean? Similar, or they're equal to each other. They have the exact same measurement. Congruent is basically talking about things being equal, but it's used a lot in geometry because we're talking about shapes and lines and angles and all those kind of things. So we're talking about how they're similar to each other, meaning that they have the same measure, they have the same size, those kind of things. So we would say when two things are equal or similar. You guys remember the symbol for congruent? It's an equal sign with that little squiggly line on top of it. Okay? So you can use this symbol when you're talking about things being congruent to each other, or if you see that symbol in a problem, they're trying to tell you that those things are congruent. Okay? Now, with lines and like we've got multiple lines in a picture, and we start getting these angle pairs, you probably, again, you talked about this probably back in geometry. There are different types of angle pairs out there. Now, I put a chart. This is from an old geometry book that kind of talks about these different angle pairs. Okay? We talked a little bit about the interior and exterior of an angle, but we have things called consecutive interior, alternate exterior, and corresponding. Are any of those words ringing a bell for you guys? When you guys talked about lines, and we had this key line called a transversal. The transversal is what cuts through those other lines in the picture. So in this one up here, T, that line going up and down, is cutting through Q and R. So T is acting as the transversal for this problem. It starts to break these angles into pairs. So if I look at this picture, I've got 8 different angles here. And depending on how they're related to each other, like are they both on the inside? Are they both in between those lines? Are they both outside those lines? Do you have one on the inside, one on the outside? It changes what type of angle pair you have. So if they're both on the interior or they're both on the exterior, they can be considered consecutive or alternate. Consecutive means that they're on the same side of the transversal. Alternate means that they're on opposite sides of the transversal. And this chart gives you all the examples of each type of angle pair here. Corresponding is kind of the weird one where you have one angle that's on the inside, one angle that's on the outside. So one's on the interior, one's on the exterior. They have to be on the same side of that transversal though. So they both have to be on the left side, or they both have to be on the right side. They both have to be above or below, however the transversal is happening in your picture here. So all of these angle pairs, like I said, I know it's been a couple years since you guys were in geometry, but you did talk about these things. And specifically, you probably got into like parallel lines and transversals, which we'll talk about in just a minute. But with these types of lines, we have different other angle pairs too. We have what's called adjacent angles. That word adjacent means next to. So if you're adjacent to something, it means that you're next to it. Okay, you're next to something. So adjacent angles are angles that have a common side. What this could look like then, something like this. Okay, I could say angle ABD and angle CBD are adjacent. They're next to each other. The shared side is this BD side in that middle. They share that one side. So that's what makes them adjacent. They have that common. Now vertical angles are across from each other. So like they're directly across each other in a picture. The key thing about vertical angles is that they are congruent. They're going to have equal measures. So anytime you have lines that intersect, anytime you have lines that form that X, they're going to create adjacent or vertical angles. Okay? Your vertical angles would be 2 and 4, so 2 is going to be congruent to 4, and angle 1 is going to be congruent to angle 3. They're directly across from each other, and they're going to have the same measurement. Okay, so coming off of this transversal talk, going over like what is a transversal and how it kind of breaks these angle parts into these different pairs. If you have parallel lines that are cut by a transversal, I've got some more kind of theorems and postulates. Again, this is something that you talk about in geometry. I took this from an old geometry book, so it may have looked different to you when you learned about it the first time. But it all means the same thing. If you have parallel lines and they're cut by a transversal, it starts to make these angles have specific types of relationships with each other. Some of them are congruent, some of them are going to be supplementary. Okay, corresponding angles are all going to be congruent. Alternate angles, whether it's interior or exterior, are also going to be congruent. Consecutive angles, so consecutive interior or consecutive exterior angles, are going to be supplementary, which remember means they add up to 180. Here's kind of a shortcut you can do for any picture that you see. If they give you something like this, what two lines in this picture are parallel to each other? Name them using the little letters next to them. X and Y. So X and Y are parallel. Z is acting as the transversal right now, okay, because it's cutting through those two parallel lines. They are telling you angle 11 is 51 degrees. What angle is vertical to 11? What number? 12. That means that 11 and 12 have to be 51 degrees. 10 and 11, you see how they're next to each other? They share this common side right here. They're going to be supplementary because they form a straight line. So what's 180 minus 51? 129. So angle 10 is going to be 129, which means that angle 13 is also going to be 129 because 10 and 13 are vertical. Now the same thing is going to happen down at the bottom here. So 11 and 15 are called corresponding because 11 is on the outside, 15 is on the inside. Corresponding angles are congruent to each other. So 15 is also going to be 51, which means 16 is 51. 14 and 17 has to be 129. If you have parallel lines, you should only have two angle measurements in your whole picture. And they should alternate. There should be like a pattern for them that you should be able to use and follow.